Hello everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we talk about linear and nonlinear functions. We're going to be looking at the two different types of functions and the differences between the two. We are in the Common Core Standard of Functions, and we're going to be defining, evaluating, and comparing functions today. Well, our guiding question as we look at linear and nonlinear functions is how can we tell the difference between the two? So we're going to be getting the definition of linear and nonlinear functions, and we're going to be looking at examples of both. By the end of the lesson today, you'll be able to tell the difference between the two. All right, here's two quick examples of linear and nonlinear. If you think about the words linear and nonlinear, linear has the word line in it. And nonlinear, it means no line. So when we think about this one, is this a line or not a line? This one is a line. And this one is curved, so it is not a line. So can you guess which one's linear and which one's nonlinear? It's that simple. All right, let's get some definitions. Well, when we're given specific data in a table or different equations, we can write a pattern from it usually. And any pattern that can be written as a line is called a linear function. Let's look at this one. A linear pattern that can be written as a line that has a constant rate of change. That is called a linear function. Constant rate, meaning it has a slope, and it is written as a line. When we graph it, it looks like a line right there. So here it is. It's no curve about it. It's straight. It forms a line. It's a linear function. All right, a nonlinear function is a pattern that can't be written as a line and doesn't have a constant rate of change. The slope changes. If you look at this one, the slope changes. It's steeper here, gets shallower, and then gets steeper again. It does not have a constant rate of change. It can't be written as a line, so it is a nonlinear function. Usually nonlinear functions are curved, or they have breaks in them, but typically what we'll see today is the curve. All right, is this non-linear or linear? Let's look at these two examples. I want you to think about comparing the parameters and the areas of this rectangle. Would you graph them and tell me whether or not they are linear? So think about it. What we'll do here is we'll take 1. The dimension is 1 by 2, so the height is half as long as the width. So let's fill these in. Take our pen here and our perimeter. If this is 1 and this is 1, my perimeter would be 1 plus 1 plus 2 plus 2. So 4 plus 2 is 6. So my perimeter is 6. Now my area would be 1 times 2, which is 2. Now if x is 2, this is 2, this is 4. So 4 plus 2 is 6, times 2 is 12 is my perimeter. And then we would get 2 times 4, which is 8. All right, can you fill in the rest? Why don't you pause the video and fill in the rest? All right, did you get them all? Let's check them. We got 3 here, so it'd be 3 and 6, which is 9, so this is 18. And 3 and 6 gives me 18. Now let's plug in 4. 4 and 8, which is 12, so that's 24. 4 and 8 is 32. 5 and 10, 15, that's 30, and 50. Would you now graph this on a graph, and let's see if this is linear or nonlinear. All right, here is what we ended up with. Now, is the perimeter, looking at the perimeter, just the perimeter? Let's compare it. We're going 3 to 6 to 9 to 12 to 15. We're going up by 3 every time. Is that rate constant? Yeah, it is. So it's linear. Whereas when we look at the area, 2 to 8 to 18 to 32 to 52, it is non-linear. Did you graph it, and could you tell the difference between a line and the curve that you'll get with area? All right, let's look at an example in science now. Is it linear or nonlinear? If a person is parachuting, here is their pattern of height versus their time falling. Starting out at 0, so they're at a height of 300, and after 1 second they're at 285, 2 seconds 270, 3 255, 4 240. Let's graph this. All right, at 0 they're at 300, so we'll put a dot at 300. At 1 they're at 285, right about there. At 2 they're at 270. At 3 255. At 4 240. All right, so is this looking linear? Is the pattern the same? You're going down 15, down 15, down 15, down 15. This looks like it's linear. Straight line there, all right? As long as you can draw it straight. You get the same pattern, constant rate there. All right, let's look at this next one. We've got the person is, if a bowling ball is falling, here's the pattern of height versus time. A little bit different. 0, 300, 1, 284, 2, 236, 3, 156, 4, 44. What's the difference here? Can you tell? Now, there is a big difference between a bowling ball and a parachute. Parachute, you've got the braking of the wind there, able to pull you as you're being pulled down. It's holding you up, and you're going down at a constant rate. Whereas a bowling ball, that same force is not there. You only have gravity pulling you down. So, can you tell if it's linear or nonlinear just by looking at the table? It would be nonlinear because the constant rate is not there. You go from 300 to 284 by 16, then you're going down by a whole bunch more. Whoa, look at that, a whole bunch more, and more even still. All right, so yeah, parachute's linear because you fall at a constant rate, whereas dropping a bowling ball, it increases and it drops so fast because it's accelerating because of gravity. It is nonlinear. All right. Would you give me 2 examples that aren't similar or that aren't like the previous ones that have to do with linear and nonlinear? Go ahead and take a minute. Think about examples here. One that's linear and one that's nonlinear of a real life situation where you'd be able to see these in play. All right, what'd you come up with? Linear, you can do anything really that relates to money, maybe the price per ounce or price per can or something like that. Nonlinear, definitely looking at something, maybe the speed of a car when it's starting and then getting on the highway. All right, what did you come up with? All right, draw this one. Tell me whether you think this one's going to be linear or nonlinear. Definitely look at the numbers there and see what you come up with. And try this one. Plot these points. See if you get linear or nonlinear. All right. All right. Well, that's going to be pretty much it for today. Can you tell the difference between a linear and nonlinear function now? I bet you can. Pretty simple distinction there, whether it's a line or a curve. Pretty easy. Well, that wraps it up for today as we talked about linear and nonlinear functions. This was Matt with mathsmath.com. Thanks for joining us. Check us out on Facebook at Solving Maths Problems and enjoy math.